Hi, I'm Afshin, and in the next 20 some minutes, I show you how to make some interesting patterns uh, by using a very simple engraving operation of RhinoCAM and utilizing the shape of the cutting tool. Let's assume that we have a 400 to 400 to 15 millimeter plywood as the raw material. And okay, let's open RhinoCAM first. The mill settings. The first thing, let's make sure we have the machine 3-axis. You need to make sure that your post setting is correct. For the machine that we're using at IOA, the post should be i/IOA. As you can see, you know where to download that. And the extension should be NCP. This depends on your machine. So if you're not a student at the IOA, then you need to check the settings according to your workshop, of course. So this is okay. And then I define the stock. I pick the upper point and the 0, XC, YC, basically 0 and 0, 15 millimeters height, 400 to 400. If I click here, I'll get an update. Okay, so here is my stock. The color of stock in my RhinoCAM is different. I changed it. If you have the default settings, probably you have it in orange color. And next thing, we need to make a setup. So click on the setup, make a setup. You don't need to change the settings right now because we are going to go with the default settings for a 3-axis milling. Okay, and renaming this setup. Okay, let's make a few tools that we are going to use in this video right now. So create edit tools. The first tool that I'm going to make will be a ballpoint tool. It would be, let's say, 19 millimeter ball. And so the holder diameter which we have here is 35 and 25. These two values are really important, these holder diameter and holder length, in 3D operations. So you need to be really careful about them when you're engaged in making 3D operation files. Here we are basically producing a 2D operation, so whatever you put here doesn't matter that much, but get used to using proper values. So the shank diameter for my tool is 8 millimeters, the tool that I'm going to use here, and the tool diameter, as I said, it is 19. Something you should always remember that when you change the tool diameter in RhinoCAM, it immediately changes the shank diameter. So you should always change it again after you're changing the tool diameter. So I go back here and make it 8. The tool length for my tool is 20, 25 actually. And the shoulder diameter is 20 and flute length is 10. Actually, it should be to this. Yeah, that resembles quite much the tool that I'm going to use for this operation. The number of flutes too is okay. The cut material color defines what would be the material color of the cut parts. Tool number, we don't care because we don't have a tool changer machine here. And make sure that your axial offset is 0 because, yeah, I'm not speaking about that in this week. Feet and speeds. For such a tool, 12,000 is good for the spindle, and have in mind these speeds are good for the machine that we are using here. So this really depends on your workshop, your machine, the powers of your machine and everything. But here actually we have quite some good speeds. All is good. So make sure you save it as a new tool. And then I'm going to make another tool, this time a V-mill actually. So it's a 90-degree V-mill. So the holder diameter again, 35, 25. Shank diameter 8. Taper angle is 45. Basically, we call this tool a 90-degree tool because this degree is 90 here, but the taper angle is the angle here. So you need to make sure that it is half of the real angle that you see in the specification sheet of the tool. Yeah, that sounds good. Okay, and the speed again with this 12,000 should be fine. The rest of the speeds are okay. Depending on the depth of the cut, we could go with 1,800 or 2,000 on this machine. So make sure you use save as new tool, because right now, if you save edit to tool, it might save it on the previous tool that you had selected. So save as new tool and click OK. Now we have two tools saved here and we can proceed. Okay, let me draw two curves here. I'm going to use this curve. So let's say 100 millimeters away from the boundary. I move it to my pattern curve, and then let's make another one as well. Okay, two curves. Okay, so I'm making two operations. First one, two axis engraving operation. We select this one for the first operation. We choose the two ballpoint 19 millimeter and the speeds you load from the tool. And sorting, we have only one curve, so we don't need any sorting. Entry, exit, none, that is fine for this operation. Cut parameters, tolerance is okay. Cut direction, natural. And this is important. Location of cut geometry at top. So this is my stock. And you saw that the 15 millimeter of the stock is below 0. And one thing I forgot to do here is to define the XYZ, the work 0 plane. So I save this at this moment. I just go back and I make a work 0. Select that. This is the work 0 that I'm going to use. Generate make sure this work zero is not under your operations and it is above. Otherwise, it doesn't affect your operation and it affects only the operations that are below that. And every time you change the work zero, you need to make sure that you regenerate your operations, your milling operations. Right now, we basically just saved it and we didn't generate anything, so it doesn't matter. We double click on the operation and we go back to the operation to define the settings. So in the tool, we have the 19mm ball mill selected, feeds and the speeds according to the tool settings, sorting, nothing, enter exit, none, cut parameters, neutral, and location of cut geometry at top. So the stock is below zero, and so location of cut geometry. My curve is on the top. If the curve was at the bottom of the stock, I had to choose at bottom. So these are settings you can check on your own later, but for now at top is okay. And then cut depth control, total cut depth, rough cut depth, and finish depth. This defines the depth of my cut. For the first operation, let's choose 5mm, and we cut this all at once. And then clearance plane, never use automatic, that's dangerous, specifically if you have a messy file and you have a lot of things there. The best things are part max or stock max or absolute z value every time you know something about it. So stock max, we defined this stock and we know that, okay, 12mm above the stock, that's a safe plane and it's fine for us. And cut transfer method in the clearance plane. So every time it goes to the clearance plane, I explain the scheme in other videos, and then now we generate that. So here we have the tool path, if we turn it on or off, and if we simulate that, so you see this is the effect of my tool. Let's make it slow. So this is what happens to the material. Now imagine that let's make the same operation with another tool. Actually, I can Control C, Control V. Let's make this EG underline 19mm ball, and this one EG underline 90° V. Okay. So this one, I remove this control geometry and I select another one, this one, and I change the tool. And let's choose a different cut depth. Here I choose, let's say, 10mm. And I cut everything all at once. So 10mm rough cut, and then rough depth 10mm at the same time. Let's see what happens. Here we have a V. First thing to know that sometimes this is a lot of material for the machine, for your spindle to be removed all at once, and it can damage the tool or burn the piece or burn the flute of the tool, so many things. So you basically need to divide these into several passes or sometimes two or more passes. So what we do, we go there to the cut parameters, and we can divide these 10mm. For these 10mm, two passes should be fine. And because our tool is a V-mill, so the first pass can be deeper and the second pass should be less deep because the amount of material which is removed with the first pass because of the tip of the tool is less, and when you go deeper it removes more material. So the first cut can be basically, let's say, 7mm, and the second can be 3. So we have two cuts, 7 and 3mm. If we generate, you see that the first cut is 7mm deep and the second is altogether 10mm, but actually the effective the amount of fluid which is engaged with the material is only 3mm. So let's simulate and see what happens. So Fine. Now, what happens if I change something about the curve? Imagine that I select both of these curves, and well, they have only 2 control points, so I rebuild them. Three control points. Okay. Then, and I move this middle control point like 5 millimeters up. Okay. If I go to the front view, you see that these two curves are now 5 millimeters above the stock. Let's regenerate both of the operations and run them again. So you see the change of the profile from the top view. Actually, let's make it more clear. So I select the curves. So here you see it only cut this much, and here like that. Just imagine how many different capabilities we have with such a simple operation. Okay, let's actually go move this 90 degrees tool to the top, remove this one, and go to the top view. For now, I turn off my simulation and I make sure that my project is on. This is something that you better get used to it whenever you are working with in the top view, specifically with milling, because then you make sure you're not messing around with the curves. I like the stock, so I make sure everything is all right. And now, okay, my stock was 400, and if I make an array in x direction 1, in y direction, let's say 0 direction 1, and the spacing, it's 400. Let's say we need 10, so the spacing of 40 should be fine, and enter. Okay. Let's copy one more there. Okay. So I go back to the engraving, remove all, select, let's select all of them. And here we can actually have a minimum distance sorting, and lower left is okay. Generate, simulate, play. So this is what we have here. And just imagine that I can select all of them and rotate them for 90 degrees. Make a copy, remove all, select, generate. Okay, simple. And you can play endlessly with these. Another example would be, I can Control Z actually, go back there, I select this, Control G, copy in place. Okay. So I go to the layer and so this time I go to the front and I simply use the scale to return, or I basically mirror these curves. Let's see what happens now. If I go to the engrave again, all select everything, generate. Too deep. This is because of the curves I basically mirrored. Now I would say 5 millimeters or 8 millimeters. I'll move them to the top. Okay, that was too much. Minus 5 millimeters. Okay, something more different now. You see, you can have a lot of different patterns around with this technique. You can play around and follow any sort of curve or whatever you would like. Okay, let me show you one example of these sort of patterns. So this video shows the actual cutting process of a pattern which is designed and implemented with a very similar technique I showed to you in this video. And if you would like to look at the file, this is the file for that pattern for the video, and you see that these are very simple NURB curves which are defining the form, and well, this is the simulation of the process that you see here.